All right, to continue our discussion of stoichiometric calculations, let's do another example. Consider the unbalanced reaction where solid magnesium reacts with carbon dioxide to make solid magnesium oxide and solid carbon. In this reaction, how much carbon is produced from 10 grams of magnesium? Well, the first thing you have to do is make sure that the reaction is balanced. And just looking at this reaction, I can see that everything's balanced except the oxygens. So I'm going to put a 2 here to bring the oxygens into balance. That threw the magnesiums out of balance. So I'm going to put a 2 here, and that rectifies it. So now I have a balanced chemical reaction. Your first step should always be to make sure that your reaction is balanced. Now you can address the question of this stoichiometric calculation. So I want to start with 10 grams of magnesium, and I know I have to convert grams to moles. So I want to look up magnesium's atomic mass on the periodic table, 24.3 grams per mole. So that's moles of magnesium, but I want to relate magnesium to carbon. And looking at my balanced chemical reaction, I can see that I am going to produce 1 mole of carbon, there's nothing there, for every 2 moles of magnesium. So I can put that stoichiometric ratio in, 1 mole of carbon for every 2 moles of magnesium. But when I'm asked how much, I probably want that in grams. So I am going to convert the moles of carbon to grams of carbon using the atomic mass of carbon from the periodic table. So now I can cross out the grams of magnesium, the moles of magnesium, and the moles of carbon. And I am left with 2.5 grams of carbon. So that's a very basic stoichiometric calculation. But now let's consider a situation where I am considering the amount of both reactants that I'm putting in. If I know how much of each reactant I'm putting in, I have to consider the possibility that one of them is what I would call limiting. So, limiting reactants. In lots of reactions, in almost all reactions, one or more of the reactants is present, what we call in excess. In excess means that there is too much of it relative to the other reactants. So, if you want to figure out how much product you're forming, you have to base your calculation on whatever reactant is limiting, whatever reactant limits the extent of product formation. So you have to do calculations for everything and find the reactant that produces the least amount of product. And that's going to be the maximum amount of product that you can possibly produce. So let's take that example that we just did, the reaction with solid magnesium and carbon dioxide producing magnesium oxide and carbon. I have the balanced equation for it here. Looking at that reaction, how much carbon could be produced if we are using 16 grams of magnesium and 24 grams of carbon dioxide? So here we need to do not one calculation, but 2 calculations. We have to figure out how much carbon could be produced from the 16 grams of magnesium. And we need to figure out how much carbon could be produced from the 24 grams of carbon dioxide. So these are 2 similar stoichiometric calculations, but we need to do both of them. So the first one is just like the one we just did a moment ago. I need to take the atomic mass of magnesium from the periodic table to convert to moles. Then from the balanced equation, I have 1 mole of carbon for every 2 moles of magnesium. And then I can use the atomic mass of carbon from the periodic table. I can cancel out the things that are the same on the top and the bottom, and that will give me some amount of carbon in grams. In this case, the calculation gives me 3.95 grams of carbon. So I advise you to pause the video and make sure that you can do that stoichiometric calculation. Now we need to do a similar stoichiometric calculation for CO2. 24 grams of CO2. Okay, so I need to calculate the molecular mass of CO2. So 12 for carbon and 16 for each oxygen gives me about 44 grams per mole. Okay, so that's the reciprocal of the molar mass of carbon dioxide. And I'm doing that because I want to get rid of the grams and be left with moles. Looking at the balanced chemical equation, I have a 1-to-1 ratio of carbon dioxide to carbon because neither of them has a stoichiometric coefficient. So I'm going to produce 1 mole of C for every mole of CO2. And the final step is just converting the carbon to grams using its atomic mass. So that calculation gives me 6.54 grams of carbon. Now notice the difference. We have to compare these two values. Which of them is less? Well, it looks to me like this is going to be the maximum amount of carbon we can possibly form. The reagent in excess is carbon dioxide. The limiting reagent is going to be the magnesium. Okay, because this is the reactant. Okay, reagent and reactant are kind of synonymous, so I use them interchangeably. So this is the reactant that forms the smallest amount of product. So the answer to the question is that 3.95 grams of carbon are formed.